Thank you very much. Excited to be here. Also want to start off by introducing our panel before we jump into today's conversation. Just starting from the far end is Steve Stratton. Steve's the Senior Director for Product Management at ForcePoint Federal. Next to Steve is Biff Lyons, and Biff is the Executive Vice President and Manager of Federal Defense and Security at Parsons. Next to Biff is Jerry Davis. He's the Director of the Information Technology Directorate and also the Chief Information Officer at NASA Ames Research Center. And to my right is Arlette Hart. Arlette is the Chief Information Security Officer for the FBI. So today's topic, as Par mentioned, is a very broad-ranging discussion that can really kind of spiderweb out into lots of different talking points. But some of the things that the panel and I had discussed in planning for today's discussion was really kind of the overlap between maintaining security, but also enhancing operations, both in public and private sector, especially when we consider the emergence of the information or the Internet of Things era, how the information has proliferated dramatically has kind of been a recurring theme from all the other discussions this morning. And so we really want to talk about how do you deal with this massive emergence of information, proliferation of information, how do you segregate that and maintain a heightened sense of security, but also allow for efficiencies in operations. And really just to kind of kick things off, first I'm going to ask Biff, from your perspective and the perspective of Parsons, how are you looking and how is your organization trying to understand this balance between both productivity and security?
Well, great, Kevin. Thank you. And thank you all for being here, for ICIT, for having what I think is a great event. So Parsons, if you don't know us very well, just a very short commercial, because often when I talk about the cybersecurity work Parsons does, they look at me and say, well, I didn't know you did that, right? Actually, Steve and I had that conversation. So Parsons is a global infrastructure company, and we do a lot of transportation projects across the world, a lot of environmental remediation, water projects that has nothing to do with the federal government so much, a lot of state and local and overseas stuff, automated transportation management systems and positive train control intelligence transportation systems. And then a few years ago, and that's what they've done for decades, they bought a company, Sparta, that got us really into the defense and security space. And we bring an awful lot of cybersecurity operational expertise that we do primarily for the federal government. And so right now, we're sort of in a great spot to marry those two things up. And we're seeing that happen in the federal government and also more in the non-federal clients that we have. And so commercial over, to get at your question, so that gives you that perspective, we've got, in talking to our clients about cybersecurity in this new world, as you described it, I tell you, there's all kinds of technology solutions, right? I think Steve and a number of others could probably talk about it much better than I can. But it comes down to risk management, right? Balancing productivity against security, it gets down to, do you know what you have? Do you know what's important to you to protect? And then how do you go about doing that, right? And, I also heard some other people say this morning, the endpoint is every one of us walking around, with our cell phones, right? So people play an important role. So from my standpoint, I think we really need to get to the point where everyone is aware. They're truly aware of what it is they're doing, what it is they have in their hand, what data it is they have access to. Because I know we sit in a room, and we probably all are, but out there as it goes, you can tell them that there are risks, or you could tell them their data is being shared, but they haven't internalized it, right? And then you've got to get people to be able to make those snap risk decisions, either personally or in a business standpoint, for business decisions to do it. I was talking with a friend of mine, last week. We were taking our kids to go see some colleges. I'm at that stage. And this young man that I was talking with, he's like, well, I don't like getting in a car that, has a modem in it or has all these things attached to it, right? He was really sort of in the space and concerned about all the risk associated with it. And so there's a person who sees risk in everything, and he's going to be a great kid. You guys should all hire him. I'll introduce you to his father. It's great. But eventually, you get this fear that people could get gridlocked. And then you got it on the other side, and they don't even know You know, that every time you walk into a room, your phone is telling everyone who wants to listen, you know, where you stayed at, you know, at what Marriott you stayed at last night, or, you know, everything along those lines. So anyway, when we look at the problem, that's what we look at. It's a holistic solution. And managing risk and the people component of it is a key piece. So.
That's great, thank you. So, Biff, just to follow up on your point, where you talked about kind of two ends of the spectrum.
Right.
All of our devices, sensor-based technologies, or disseminating information, how do we track and control the dissemination of that information? Jerry, from your perspective, and NASA, really from kind of a conceptual or a strategic level, when you're looking far into the future, future project development, understanding all of the very complex nature of sensor technologies involved in NASA's research, where do you see that balance between maintaining security in a rapidly evolving ecosystem, but also being able to operationally scale out?
Yeah, so interesting enough, you know, this problem around security, or the challenges around security, and the way I've kind of characterized it, the way I've looked at it over the years, and not specific to NASA, but just kind of everywhere I've been, is that we're at a turning point now where I felt like, and I like to say that, you know, we've admired the problem long enough, right? So there's a problem that we've out there, we've admired it for years and years and years. And so from a strategic perspective, what I've been looking at is more getting back to the basics. And Ron Ross talked a little bit about that, and back to the engineering side of cybersecurity, building into engineering solutions and devices and things like that going forward. At NASA, it's extremely difficult when we talk about data protection and getting data out to the consumer, to our constituents out there. Part of our charter is to take technology, take data, and get it out to everyone. We work with scientists and researchers all over the world, so we have a very, very open environment. Trying to bring that down to where you have a level of security and a proper amount of security for that data is really a challenging and kind of a vexing problem. So again, one of the areas I've looked at again is the strategy around that is starting from the ground up, engineering those solutions into our engineering sets, into our technology early on. And later on, I'll talk a little bit about that, but I definitely believe we're at the point where we have to get back to trusted systems. You know, how do we authenticate the systems? How do we design systems from the ground up? We've just gotten away from that, and it's gotten out of control. We have to bring that back, doing research in those areas, applied research is, I believe, the things that we need to do. We're going to get into some training aspects of that. And then there's a very, very large and complex, what I like to believe, information sharing. How do we do information sharing the right way to get things back out to the folks, to the community of practice? So it's not an easy problem, but NASA, we're kind of known for solving what are presumably intractable problems, and it's good that we have a lot of smart people that we can work these things with, but we're definitely working at it.
Great.
Towards it.
Thank you, Jerry. Steve, from your perspective, you know, highlighting one of the points that Jerry just made about, you know, emergent technologies and kind of rapid evolution of softwares, we think a lot about the kind of government and or public-private overlap, how there are certain government requirements and different private sector companies are able to come in and help expedite unique solutions. Really from your perspective as far as dealing with the changing kind of threat landscape and different attack vectors, how do you see new software, intelligence software, learning software evolving and helping fulfill some of these open requirements?
Well, that's a great question. We have a great underpinning and a capability to track user activity and user behavior. But that's not enough. We've got so much else going on, like was said, sensors, supply chain, other connection points into what used to be our perimeter. And we need to be able to take that data, look for anomaly detection. It was mentioned earlier, what is inbounds data? What is the kind of data we expect? When you're making connections into SCADA systems, it might be a good message, but is it the right message? Is that fuel tank already full? Now you're causing an overflow. And so we need to understand context. And so part of what we're looking at is how do we collect data from places we haven't done in the past with legacy systems? How can we model a SCADA system? What's normal behavior to look for those anomalies? And this gets back into also what I think is important in the NASA space and some other spaces too, is how does that relate to, say, overall safety, right? Just not do we have malware, but do we have things going on that are unsafe in their context? So we're looking at different ways to collect data. Also, how do we use advanced systems like we use in the DoD and the IC to share data securely, that do more advanced content filtering, even transformations? The NSA, of course, is asking us to do protocol breaks to defeat malware. And so from an information sharing standpoint, I think we've got a lot of good experience to share with the commercial market. And we have some customers in the financial space that just happen to have some people working at them from three-letter agencies that get this idea, get the idea of segmentation, of networks and layering, and then secure data sharing. So I'm looking forward to more growth in this space in the future.
Great, thank you so much. So Arlette, as we kind of have heard from both from NASA and in the private sector as well, and also kind of a shifting landscape where some people are leaving the government, going into private sector. Perhaps they've had some of that past either DoD or IC experience, but then you're working at large corporate industry offices, and you're recognizing that some of your work becomes kind of a national security challenge. How can private sector companies become more engaged with the FBI? And at what point can the FBI come in and say, here's how we want to discuss information sharing. We want to enable companies to continue to be productive and secure, but we also, from a federal law enforcement perspective, there are some things about this evolving threat landscape where we should sit down and have a conversation.
So we're crossing authorities here.
Right.
So FBI is a reaction. We react to, we can provide recommendations and things like that. The best way to engage with the FBI is to join InfraGard, and everybody here who is not a member of InfraGard should join InfraGard. There's also DSAC, and also get to know your friendly neighborhood FBI agent and response people. We have an entire division devoted to cybersecurity and cyber response. And make sure you know who they are, because if you have an event, you don't want to have that be the opportunity for you to figure out how to address your event, right? This is turning into the fire drill of this generation. You make sure that you know how to do your response, you know how to escalate it, you know how your CEO gets notified of whatever it is that's happening in your infrastructure. And those are absolutely the best ways. InfraGard, get to know your local FBI agent. You can go to whatever law enforcement agency you want, by the way, because we coordinate. We have the NCI-JTF, which is a coordination function, the National Cyber Infrastructure Joint Task Force. Coordinates amongst the IC and state and local organizations and across the board, and we also work with our foreign partners to make sure that we have a continuous response capability and that we work with you. By the way, one of the things, every once in a while people are like, and then the FBI is going to come in and they're going to take all my stuff. We're not doing that. We treat victims as though they are victims. This is a crime that has happened to you. Our objective is to make you as whole as we can in the face of that crime. So we send FBI agents. We often have victim assistance. People come in and work with you to mitigate that crime and to do what we can. We also put some capabilities in place if needed to see and to go back through and say, what happened to you? What can we characterize and go back and do some attribution? By the way, attribution is really important in this field because knowing who did things, both you can buy your little hacking kits just, the same way you can buy any other, open source software, except it's not, but you can buy those. And so we try and find out who the source of that information is and really go back and make sure that we disrupt the supply chain from that side too. So those are pieces, my ad for the FBI. It's like, please get to know your local agency. Make sure that you have law enforcement working for you. We are here to make sure that the critical infrastructure continues to exist. DHS, we also work very closely with DHS, of course, whose job it is to say, here's how you need to protect yourself. Here's the pieces that are in place. Joining your ISAC is also an important consideration. Make sure that you know what they're doing and leverage as much intelligence as you can find. We provide access to different pieces. The ISACs provide access to information that is critical to your particular infrastructure. And those are really important components to this.
Thank you so much. Biff, I want to go back to kind of earlier, before you jumped into industry, you finished a PhD in physics. So having that kind of deep knowledge and understanding of technology, what are some of the advantages or opportunities that you see in evaluating new threat vectors from an industry perspective, where you can take that background and experience and help evolve new products and new solutions, and then explain that to some of your clients?
Right. All right, that's a great question. So, like just about solving just about any problem, what's important is to understand the domain that you're in. You know, and so with a background in physics, which I haven't really exercised in some time, I would say, but what you can understand is the technology that's out there and how it has an impact on the physical world around you, right? Whether it's a mechanical system in a plant that's being operated by a control system, or electronic systems that are operating our networks, everything along those lines has a physical reality, right? So understanding that response, and one of Newton's first laws, you know, every action has an equal but opposite reaction, allows you to then go back and do analysis, do testing, do real research and development to understand what makes sense. And then you need engineers, right, to make it work. Right? So for me, it's been pretty invaluable, and then hopefully I think, you know, for the company, the types of people that we bring forward gets at what's the domain we're operating in, right? How do all of these things interrelate and have a physical impact on your mission and on continuity? So.
That's great. Thank you. Jerry, from your perspective as well, just circling back to NASA, can you help us better understand the roles or the interaction that you have with different critical infrastructure organizations as well as government agencies, and also extending that to outside contractors or consultants? How does all of that kind of come together within the research center?
Yeah, so when you look at NASA across the board, when you look at the different centers, so there's basically about 10 primary NASA centers. When you look at those centers from an infrastructure perspective, you'll notice that of the 16 main critical infrastructure sectors that we have today, that at all the NASA centers, there are microcosms of those critical infrastructure sectors at each of those centers. We have power substations, we have healthcare facilities, so on and so forth, obviously computing resources and things of that nature. So when I kind of looked at that environment, I said, you know, we are a microcosm of the 16 critical infrastructure sectors that we have here, and kind of what are we doing from a protective standpoint, and understanding those environments, what are the threats and vulnerabilities lodged up against those. So one of the things that I do, being lucky enough, being out in Silicon Valley, is I have the opportunity to talk to a lot of the innovators out there and one-on-one and have these discussions. For instance, it is almost on several times during the month, I'll get calls from VCs, venture capitalists, who will say, hey, Jerry, we've invested some dollars in this company. This is what their design is. It's a cyber defense product. We'd like you to come out and take a look at it. Now, obviously, I can't endorse a product one way or another, but I can go out and look at it. And the good thing is I'm looking at something that's anywhere from 18 months to 36 months out from being released out into the world. And I can look at that and I can provide some feedback on that, and at the same time, maybe take an instance of that and put it in my environment and see how it works against some of the issues that we may have in the environment. So that's one of the key elements, key areas that is an advantage to living and working out in Silicon Valley. I would say the other piece is working with folks like DHS. NASA, with our brand, it's known worldwide. So obviously we deal with a lot of issues from a threat perspective. Recently, in the last week or so, actually did some work with DHS on their ICS-CERT side of the house. came out, looked at some of our infrastructure, and we had an open dialogue about the things that we were doing, helped us do some lessons learned, some issues that maybe we potentially have in our environment that are applicable to all the NASA centers. So that's my contact points with the private industry and then federal. We make sure that we maintain a good relationship and that we take it upon ourselves we have a lot of smart people at NASA, but we're not arrogant, to believe that we own all of the intellect there at NASA. So I reach out a lot to where there's academia, private industry, other government agencies, to try to bring in from that community of practice all that knowledge. And those are just a couple of examples that I gave you.
Great. Thanks so much. I would encourage the audience to start kind of thinking about some of the questions. I'm going to pose one last question to the panel, and then after that, we're going to turn it over to everyone for Q&A. I'll pose this question, Steve, to you, but I encourage everyone on the panel to feel free to jump in. So to one of the points that Biff made earlier about your endpoint device and how that's emitting information, can you talk a little bit, or can everyone talk about how that perimeter is no longer necessarily kind of the network at work or the office, but the perimeter is really the individual and the individual endpoint device, and where that's traveling, where it's located, and with which other devices or infrastructure it's communicating with. So from a kind of threat vulnerability perspective, how do you develop new intuitive software that can kind of model and track and understand those behaviors and then respond to them?
Well, it's every time you touch your iPhone, there's about 100 events that hit even just the billing system. It's looking at what you do every time you touch the phone. And so we can collect that data if that's important. There are other technologies you can use that actually do secure redisplay. That means that I'm creating a secure tunnel back to data that stays in my data center. So you can, in fact, have your BYOD. You could have your team out using whatever device they may have or a supplied device, but then have that secure connection to the back end and collect data even from that connection. So there's a couple different ways to look at it. I tend to be more on the secure redisplay. I don't want to have to deal with all those different devices, all those different flavors of Android or iPhone or whatever it might be, and I would rather create that secure connection and have control over what is seen, especially my most sensitive data, once again. Modeling different users in your organization is something we're looking at from the greater UEBA space, and then looking at how do I look at your activities based on your peer group, for example. How risky are your behaviors today versus your peer group or other parts of the organization, such that I might want to take action. I might want to monitor you more. I might want to shut off certain capabilities, use geofencing to cut off certain services, things like that. There's some great things going on with wireless geofencing, inside and outside the room kind of capabilities that we're testing out. And so there's a broad array of technologies. The question is, once again, in your space for your business, what is the right behavior and how do you understand that? So we're working with data scientists in several different companies, even people machine learning like Cylance. We've incorporated Cylance capability into some of our detection stacks for malware, just because we want to stay the state of the art for our customer base. So it's an interesting question, and we're going to continue to run after that solution.
So imagine what you can do with the data, right? When you have all of that, not just either with or without their knowledge, giving them particular access, but you've got a lot of people that may just be unaware that their behavior is risky. So targeted training activities, targeted communications that you'd have that of any sort. So it's a question then of not just how can you get at the data and what does it mean, but what do you do with it afterwards, right? So that's great.
Absolutely.
Yeah, and I would say that's some of the areas that we're looking at from a solution set perspective. And I'm always a big believer. There's some very, very common kind of simplistic rules that you follow around security, and that's separating the users from resources, right? And I believe as it comes to data, I've always been a big believer that me as a user and as a person of protected of data is not to let users have data that resides on their devices and things like that. I'm very big into VDI environments where you're just seeing an instance of the data. It resides somewhere safe and secure where I know it's going to be, and you're just looking at instances of it. So I tend to push those kind of technologies, segmenting users and networks from resources. And then, as was said earlier, monitoring user behavior and activities. We're seeing more and more behavior analysis, machine learning type technology that's out there. It's getting really, really good. And those are the types of things that future-wise that we're looking to invest in from a behavioral analysis perspective.
Thank you.
To my mind, these sound like data that's generated internally as opposed to externally, and there's an element of disruptive technology that is actually, to me, throws a wrench into the whole thing. It's not sufficient to protect data once you know it needs to be protected. It needs to be protected at the ingress. It needs to be protected from the disruptive technologies and understanding how information is gathered and when it becomes valuable and what the data lifecycle is. I'm not sure that the device itself is the endpoint. I kind of go between it and the data being the endpoint. And so am I protecting the data? Am I protecting the device? I think there's both sides of that need to happen. And when you look at the critical infrastructure component, the pieces that get hard, it's like if we could keep SCADA into a box that never got touched by the outside, SCADA would work forever without ever being patched, in 1926 technology. That's not the problem. The problem is that the technology is interfering into the SCADA systems and the other systems that we've been saying, okay, well, this is protected by this particular wall. And it's like, and as we go down, it's like, oh, but in 1998, people brought Furbies into the NSA. It's like, I don't know how many of you remember this, but it was like, all of a sudden it's like, wait, you're not allowed to bring this cute, fluffy little thing in because it records everything that you're saying, right? It's like, this is barely technology at that point. And it's like, and it's interfering in your operational capability and it's putting you in jeopardy. And these are the things, and that was trivial. When we look now, it's like, what are we bringing in by accident? What are we bringing in on, and how do you actually, what do you do with the heart monitor that has to go back to the hospital when the person's in a protected environment? These are questions that make it harder because it's like, well, do you do it by exception? Well, what if somebody's these are the questions that make the whole question more complex. So I think the way we think about it kind of fundamentally has to change, not just, are we monitoring more? Yes, there's a point where it's like, if you get much more data, then you can actually do, a crowdsourcing verification approach to that. It's like, yeah, I've got lots and lots of pieces, all of which say orange, except for this one says blue. And so, okay, blue must not be right. I should look at blue differently. Yeah, that's anomaly detection. I get it. But with the amount of data, finding the blue versus the other blue, and just the questions, and then you get these data sources. And we always look at this in terms of, well, just aggregate all your data, right? Just bring it all in. I think it's easy, but other people seem to think that's hard. So, just getting all the data in, making sure that, okay, so it doesn't happen by magic. People have to do things in order to get data into your infrastructure. So all of these, and then you have the unexpected technology intervention, and I think it just turns it into a problem that I'd like it to be easy, but it just never is quite that easy, just to me personally.
And that's a unique challenge. I'm going to turn it over to the audience for questions. Sir, please.
Yeah, I just, with respect to cyber becoming less and less isolated and more of a coordinated tactic within an overall strategy, how have you seen intelligence systems and processes interact? We have pretty mature classical intelligence systems and processes. Have you seen those start to meld, and in what ways?
If I could, we're extremely aggressive about the intelligence systems. We're working with how do we really go down this path and make sure that we make a difference. Try and support every intelligence sharing effort that I can ever find. It's like, no, let's work together. We have an overall infrastructure, we got to bring it up. You know, people have got to all be working together. Sorry, I don't mean to lecture, but you know, it's like the problem is at this level right now, we're in the weeds, we're in the mud, we can't get out of the mud at this point. We talk about critical infrastructure, but you know, everybody who makes a decision to put a thing into their house and not patch it, every old system that lives is a source of potential vulnerability. So we look at this and say, here's how we have to do it. You know, in the government, we say, we have the continuous monitoring component of it, and we say, you have to go with this, and you have to reach this level. In the private sector, we also need to help people get to where they need to go. It's, you know, well-to-do companies can do things well, and they have the money to do that thing, but how are we protecting the rest of the infrastructure? It is a place that DHS is stepping up to, and they're working very hard on that. From the critical infrastructure and making sure that we have the protections in place, again, we have a whole of government initiative on this to drive the protection capability, and it does go very aggressively down intelligence, go through AI, through the entire scope of how do we do it better, faster, you know, and you heard earlier about NASA, NSA and DHS, and I'm sure NASA too, I don't mean that you're not, but they are, and we're a part of that too, the FBI, and saying, how do we really protect this infrastructure in a different way entirely?
I'm sorry, it's like anything else, right? We just described this situation where there's all this information out there and we're trying to be able to share it and we're all down here in the muck. All of that is true. And then when you do provide it to somebody, how do you make it at all rational and meaningful to them, right? So that somebody can make an informed decision that while, and this is anathema to some technology, you know, to some of our smartest guys, well, why, you know, that while there is a vulnerability here, it may not make a meaningful difference to your business or to your mission. So don't worry about that, right? Don't protect that part. But this one, well, of course, I mean, you got to understand the whole chain.
Right. Mm-hmm.
But the issue being, you know, understand which parts is meaningful, because nobody has an unlimited budget either, and it comes down to time and resources and money. So it's not just all the data and do you have it, but which parts of it are meaningful to you and has the biggest impact to your mission, and that's where you spend your resources, right? So.
Yes. Next question there to the back, please.
We in the Air Force have started looking at cyberspace and Internet of Things as kind of being composed of three bins: your traditional IT, your OT, and then platforms. And you know, everything is, we understand IT, we're starting to move towards OT, there's a lot of work being done there. What about platforms? How do you see us defending things in the future, cars, trucks, planes, boats, space shuttles? We've come to understand that these are full of embedded IT. They have proprietary software. They run all sorts of different things in different boxes, architected in ways that nobody knows. How do you get after defending those platforms?
So, you should come to my 1240. But at any rate, so that's one of the areas that I've been looking at over the last year or so. And I kind of started with what I call, how do we look at things that is what I call emerging infrastructure or remote infrastructure. So when you're talking about a spacecraft or something that's going to deep space, how do we look at that? How do we engineer out the vulnerabilities that are going to be resident in that before we put out that field technology? And we kind of look at it, or I've been looking at it kind of in 4 steps. It goes back to R&D, T&E, applied. It goes back to test beds or cyber range type activities against whether it's new technology, test new technologies out, the defensive technologies. And it goes into, we then go into a training aspect of it, a deep training aspect, and then there's this information sharing aspect of it. So those are kind of the 4 main features that I've been looking at over the last year. And in trying to create an environment that is set up to engineer in cyber defensive and resiliency before that technology is fielded. So had a lot of conversations with folks in the Air Force about that, and that's one of the main platform that I'm looking at. It goes into when you talk about anything connected, right? So whether it's vehicles, we're looking at autonomy, whether they're UASs, whether they're vehicles, whether they're aircrafts, all those things is trying to build a platform for platforms to do that testing and research in that area and validation.
Thanks, Jerry. We have time for one last quick question, gentleman here in front.
So can we discuss predictive analytics, where we are with it, the direction? Predictive analytics, where we are with it, where we're going with it, how can we integrate it into an offensive platform? Because as we discuss protecting critical infrastructures, it's not just about a defensive posture, because we're not going to win a war that way. We have to go to an offensive posture to win the war. So how can we incorporate in these predictive analytics and make it a positive outcome?
So from the software development perspective, it's easy to do. There's actually a relatively short line to predictive analytics. Can your software be patched? Is it patched? And do you have a patch cycle that you run through? And if not, are you using that module? And if you are using that module, how are you protecting it in a way? So it's like you don't have to even so predictive analytics in some way, and I know this isn't what you mean by that. I mean, that's the big data, who's going to be bad and how's the bad thing going to happen. But the bad thing is going to happen by bad code, right? I mean, I realize that people are like, oh, 80% doesn't mean that. If you patch your code or have patchable code, you are much less vulnerable, like levels of magnitude less vulnerable. If you have code that cannot be patched, cannot be maintained, cannot be secured, you are much more vulnerable, especially if it's widely used across the environment, right? Across everywhere. So one of the pieces of predictive analytics is how good is your base infrastructure? How good is it goes back to the trusted computing. It's like, how good is your base? If you can't protect your base, and if you don't know how strong it is, and if you don't have secure coding built in, I can predict that one. I know that's not what you mean by predictive analytics. I'll actually leave that one to you.
Predictive analytics, interesting. I think building an autonomous self-healing or this kind of self-patching and things from the intelligence feed is an important idea. There's so much that goes on a large enterprise, whether it's Alphabet or GE across the world, things like that, that I don't understand how they can ever keep up with that. And so the idea that we can take source feeds and then use that to make decisions about, once again, about access to data, about turning off and on network segments, while we take care of what appear to be trouble on the horizon, is something that I think is still in the science and maybe some part science fiction realm right now. But I like the idea. I like to think I have my own predictive analytics about if I eat that spicy food, it's not going to work for me. But when it comes to big enterprises, I think it's a very tough question at this point.
So I would actually say one other thing about predictive analytics, because there's two sides of it. One is, can I predict something before it happens? But the other is, can I detect it at a short time horizon?
Right.
Which is also a sense of predictive analytics, because if you are looking at your event that looked like every other event, but it has enough distinguishing features that you can say, okay, that actually is an event that is differentiating. And that, I think, we're getting closer down that path. Still, crowdsourcing by far is the most effective of those kind of ways, because the anomaly detection with multiple feeds and multiple data sources is more effective than trying to discern by one individual looking at large amounts of data.
I would just say, just kind of close it out, that in short, I don't think we're there yet with predictive analytics. There's a lot of computational resources that we could throw at it. We looked at it. At least, in my mind, I've kind of looked at it from throwing at the supercomputing resources at it. It's a really complex problem. I've looked at it from throwing, at Ames Research Center where I am, we have a quantum computer or quantum annealer. Even, predicting how that works, right? To do predictive analytics is a tough challenge for us. So predictive analytics, I think it's still out there on the horizon. I still don't think it's there yet, but I am at least hopeful that, I think in the rest of my lifetime that we'll get there to some predictive analytics solutions.
Thank you, everyone, for such an engaging conversation. Thanks to all the panelists, to Steve, Biff, Jerry, and Arlette. I would encourage everyone to find any of the panelists during any of the breaks and continue this stimulating conversation.